Hello viewers, in today's class we are going to discuss one important limit from differential calculus, right? So here we have to find this limit when x tends to 2 plus e raised to 2x, and here we have signum of the fractional part of x minus 1, right? And here we'll call this limit as L, and here we see this positive sign. Now this positive sign shows that here we have to find the uh, right hand limit of this function when x tends to 2, right? So here we have x is equal to 2, and this positive sign indicates that we are approaching towards x is equal to 2 from the right of x is equal to 2, right? So let us start, and here what we will do, we'll make use of the definition of signum function and the fractional part function, right? So let us first take the definition of signum function and fractional part function before proceeding further. Now see, we know that the definition of signum function, that is signum of y, is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 when y is 0, and signum of y is equal to negative 1 when y is less than 0, right? So it means that if we have this as the real number line, and here we have 0, right? So all these values which lies from minus infinity to 0 are less than 0, right? So here the signum of y will take negative value, and here in this interval, that is from 0 to infinity, where all the y's are greater than 0, signum of y will take plus 1 value, and at this point, that is y is equal to 0, signum of y is equal to 0, right? So this is the definition of signum function. And the fractional part function, that is fractional part of x is equal to the difference of x and the greatest integer function, that is the greatest integer of x, right? And here the domain of this fractional part function is the set of all real numbers, and the range is from 0 to 1, right? It means that fractional part of x, the range is from 0 to 1, right? Okay, so once we have seen the definitions of signum function and the fractional part function, we can utilize these two definitions for calculating this limit, right? So here what we will do, we'll take x is equal to 2 plus h, right? So here h is a positive quantity, but it is a very small quantity, right? So we'll take x is equal to 2 plus h, and when x tends to 2, obviously h tends to 0, right? So now we can write this limit L in terms of h. So we have limit h tends to 0, and we have e raised to 2, and in place of x we can replace it by 2 plus h. So here we have 2 plus h, and here we have signum of greatest integer, here we have the fractional part of x. So this fractional part of x can be written as x minus greatest integer of x, and for x we can write 2 plus h, and here we have 2 plus h, right? So this fractional part of x can be replaced by this term. So we have 2 plus h minus greatest integer of 2 plus h and minus 1, right? So now here what we will do, we'll now try to assign value to this term, right? That is greatest integer of 2 plus h. Now see, when we add h to 2, because h is greater than 0, it means h is a positive quantity, but it is a very small quantity, right? So whenever h is added to 2, 2 plus h is obviously greater than 2, right? Or in other words, we can say that 2 plus h is slightly greater than 2, but it is always less than 3, right? So by definition of greatest integer function, the value of greatest integer of 2 plus h is equal to 2, right? So this term can be replaced by 2. So now we have limit h tends to 0. We have e raised to 4. This is 2 to the 4. Then we have 2h, and here we have signum of 2 plus h, and for this term we have 2, so we have minus 2 minus 1, right? So now we can simplify it. So we have limit h tends to 0. We have e raised to 4 plus 2h, and here we have signum of this 2 and this 2 get cancelled, so we have h minus 1, right? Now see, here we have an important term inside this signum function, that is h minus 1, right? Now viewers, this term h, or this quantity h, always lies between 0 and 1, right? So when h lies between 0 and 1, then obviously h minus 1 is less than 0, right? Because h minus 1 would be a negative quantity, right? And whenever any term which is inside the signum function, it takes the negative number or negative quantity, then the value of signum of that term is equal to minus 1, right? So signum of h minus 1, right? Because h minus 1 is less than 0, and when y is less than 0, obviously signum of y takes the value minus 1, right? So h minus 1 is less than 0, and if we take h minus 1 as y, so y is less than 0. When y is less than 0, signum of y takes the value minus 1, so here we have minus 1, right? So now here we can take minus 1, so we have a limit h tends to 0, e raised to 4 plus 2h, and here we have minus 1. So now in the next step, as h tends to 0, so when h approaches to 0, here we can take 0. So we have e raised to 4 plus 2 times 0, and here we have minus 1. So this is e raised to minus 4, right? So the value of this limit is equal to e raised to minus 4, that is 1 over e raised to 4, right? So viewers, this is how we solve this important limit.